Hello everyone, and welcome back to the Fluctus channel. Developed in the 1950s, the Boeing B-52 is a strategic bomber with a large payload capacity and a long range. The United States military deployed the B-52 in the Cold War, the Vietnam War, and several other war zones, such as Iraq and Afghanistan. It is capable of flying up to 9,000 miles while carrying up to 70,000 pounds of ordnance, which is why the U.S. military has been using the B-52 for almost 65 years and still plans to keep this iconic aircraft flying for several more decades. The B-52 is capable of carrying both conventional and nuclear weapons, which are loaded by a specialized team of munitions airmen. Initially, the airmen transported weaponry from the storage to the hangar bay using bomb lifts and jammers. The B-52's bomb bay is opened manually, and the airmen, while standing on folding ladders, physically align and mount the munitions onto the designated loading points of the B-52 bombers. Boeing designed the B-52 in a way that allowed it to carry multiple bombs at a time. While this was effective, it did not allow the aircrew to alter the weapon type mid-air. For this reason, the B-52 was upgraded, and a new technology named Common Strategic Rotary Launcher, or CSRL, was introduced, which could not only carry a range of missiles, bombs, and smart munitions, but also allowed the aircrew to quickly change the weapon type at the flick of a switch. CSRL not only offered significant firepower, but also dramatically increased the overall mission flexibility. It takes almost 11 hours to load the CSRL with weaponry. Once fully loaded, the crew puts it on a trailer attached to a vehicle, which transports it toward the aircraft. For installation, the rotary launcher is placed exactly below the bomb bay of the B-52 aircraft. The CSRL is then raised and mounted inside the bomb bay, leading to the final step of the installation, which is closing the bomb bay carefully. The main advantage of rotary launchers is that they can be loaded with a variety of ammunition that can later be launched separately and systematically, as per preference based on the rotary system. Once loaded with ordnance, the B-52 is ready to roll. The U.S. Air Force takes less than 10 minutes to kickstart the engine using explosive charges and get the B-52 in the air to carry out bombing campaigns. As the B-52 reaches the mission location, it releases the munitions out of its bomb bay, leaving a trail of smoke behind. The U.S. Air Force has also launched hypersonic missiles like the Boeing X-51 Wave Rider from the B-52 Stratofortress. The X-51 is an unmanned research scramjet experimental aircraft that can fly at speeds of Mach 5 or approximately 3,300 miles per hour. As the name implies, the Wave Rider remains airborne using the compression life produced by its high-speed shock waves. The X-51 resembles a missile much more than an aircraft, mainly because it cannot take off from the ground itself. Rather, it is launched from an airborne B-52 Stratofortress. Unlike traditional weapons that are loaded inside the bomb bay, the X-51 is attached to the left wing of a B-52. However, its launching mechanism is quite similar to that of traditional weapons. Once launched, the X-51's direction can be changed using a series of fins located at the rear side. As the X-51 is capable of attaining hypersonic speeds, the experts suggest that scramjet engines are the key to unlocking the next level of high-speed capabilities. For this reason, various flight tests were conducted to get as much data as possible from the X-51 and incorporate this information into future versions. The X-51 took a total of 4 flight tests. The first was conducted on the 26th of May, 2010. During which the X-51 reached a speed of Mach 5 and flew for over 200 seconds. However, it did not meet the planned 300-second flight duration. The Wave Rider made history on May 1st, 2013, when it attained a speed of Mach 4.8 and flew for 210 seconds until running out of fuel and plunging into the Pacific Ocean. It was considered the longest air-breathing hypersonic flight, which put an end to this program. The data collected from this flight was used for practical applications of hypersonic flights, such as a missile, reconnaissance, transport, and air-breathing first stage for a space system. Private companies like Stratolaunch are trying to develop aircraft capable of attaining supersonic flight. Recently, they conducted the first successful test launch of the hypersonic TA-1 Talon A test vehicle on March 9, 2024.
The goal is to release get engine ignition, accelerate, punching through the transonic and high supersonic regime, and then bringing it down into the water.
The massive 6-engine rocket launch aircraft took off while carrying the TA-1 Talon on its specifically built centerline payload station. The TA-1 Talon was launched at an undisclosed position over the Pacific and flew away from the rock launch aircraft while climbing in a flight profile reminiscent of the X-15 test program in the 1960s. The TA-1 achieved what was described as high supersonic velocity, which suggests that it may not be Mach 5 plus, which is considered hypersonic speed. At the end of the experiment, there was an attempt to recover all or some portion of the TA-1 launch vehicle. However, the aircraft in its current version is designed to be expendable. In the U.S. Air Force, a munitions squadron is responsible for building and assembling different types of munition for the B-52 Stratofortress. On October 16, 2019, the airmen assigned to the 2nd Munitions Squadron built 30 non-explosive BDU-50 bombs. Each component was thoroughly inspected and tested before it was attached to the bomb. A cart carrying the BDU-50s was towed to the location, and the components were lined up by the airmen, ready to be attached to the BDU-50s. After inspecting the bombs from both inside and outside, airmen scrapped the caps onto the BDU-50s and ensured they were secured properly. Later, they screwed fins on the rear side of the bomb, which are used for mid-air directional control. This exercise required the airmen to follow proper steps and ensure the bombs were built correctly. Bombs are sometimes deemed out of order, so the U.S. Navy and the Army formed an alliance to take unserviceable Navy bombs, refurbish them, and return them to the warfighter in new-like conditions. When bombs come to the crane, they are inspected to determine whether or not they can be repaired. The most common defect that makes the bomb unusable is damaged coating. The bombs considered repairable are placed on a conveyor system to initiate the renovation process, including thermal coating removal, recoating, curing, and palletization.
Robot will take the high-pressure water jet nozzle and it will traverse down the profile of that bomb, and it's removing all the coating off of it.
The evolution of bomb technologies from traditional B-52 bombs to cutting-edge innovations like the X-51 and Talon 1 reflects a continuous pursuit of precision, efficiency, and adaptability in modern warfare. The The ever-changing sizes and designs of these bombs highlight their strategic importance in diverse operational scenarios. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.